Okay, General Tribute Product Video Training. We're going to talk now about the most common calibration error. It says out of range. Okay, and currently we're looking at pH, and there's going to be two different videos. One's going to be connectivity, one's going to be pH. There's a little difference in the sensor, whether they're linear or not. Now, pH is a linear scale. It does go 0 to 14, but the sensors read in a positive and a negative millivolt, going to 0 on both of them. So the sensor isn't necessarily as linear as it is, because when it gets to 7, you'll notice the correction factor is a lot different, because 7 is supposed to be 0. Really isn't a whole bunch of correction you could do on 0. So, and we'll show you here what I'm talking about. Now, out of range means that what the sensor thinks it is, we can only adjust to what the controller will allow it to. Now the controller will go on pH 0.2 to 1.2, whatever it believes it is, and not on the pH scale, but on that millivolt scale that we talked about just a little bit ago. So we're going to look at it right here real quick. Right now it's on the pH. We're going to go and we're going to look at this raw value. Okay, you can see the raw value of 4.3 millivolts. So right now it's in a 7 pH buffer. We're going to switch it to a 10. We're going to watch it go to negative 150, 160, 155, 156 millivolts. I'm not really going to clean it off very good, but we're going to put it into 4 pH. You're going to see it go to a positive 155. This is the one that I told you about. Plus 155, 0, close to minus in the 10 range. So you can see how the thing does. Now, it'll allow you to adjust what it believes that it is. Right now this is 4 pH or 155 millivolts. It'll allow you to do 1.2 times the 155 millivolts, which would equal then the pH change. You know, it gets diluted in there, so you can't really figure it out. It's not as easy as you'd want to figure it out, but about minus 160 for pH. You'll see this goes almost to 0. And I gotta make sure I stir it just a little bit. 8, 6 millivolts, 5, 4, 3 millivolts, 3 millivolts, 2. Okay, so we're almost at 0 millivolts, 0.1, 0.7 millivolts. Perfect. Correction factor though on that's a lot lower than, because you're at 0, you really can't multiply against 0. And then we're going to go to, I'm trying not to spill these things, we're going to go to the 10 pH, and that's what you get. So when you see out of range, it's because the correction factor can't happen because of what it thinks it is versus what it actually is. So if you were to take this and scale it out, 10 pH equals minus 162, and 7 pH equals 0, you'll see that you have 3 pH increments in between there. 150, 160 millivolts divided by 3, you're going to see that that's what your increment of change per pH value, and then you can't change 1.2 times that. So that's what it means out of scale on pH. When you see it out of scale, it doesn't necessarily mean that they can't read it. Also, the first thing you very, very much should do with any pH when you're doing a calibration, remove it from the line and check your wiring just to make sure. Okay? Really to the first two. Then to go ahead and test your values and see your millivolts. pH, again, 0.2 to 1.2 times the scale.